All right, so thanks everybody for being here. Today we're going to dive a little bit into vibe coding, this exciting, fast-paced way of developing with AI. However, we're going to be discussing a crucial aspect. We're going to be securing what we feed the AI as well as what it's giving us back. So before I get started, who am I? I'm Stephanie France. I'm also known as the Handsome Zebra, and I am your neighborhood-friendly DevOps engineer. And I spend a lot of my free time lurking in the hacker world. My specialties are containerization and pipeline automation, and I could talk all day about Kubernetes or Cloud Foundry or Jenkins pipelines. But DevOps isn't just tooling, it's a mindset. And my day job involves working really closely with developers to make sure that the deployments are as seamless as possible. And I'm ensuring that all of the systems are working reliably, issues are caught early, and that teams are collaborating effectively. And because of that hacker mentality, security is always at the top of my mind when I'm designing my solutions, because I have a goal of making the cloud a safer place, one container at a time. So while I'm up here on stage, I need to make a special note that all of this is a reflection of my experience and knowledge, and it's not affiliated with my employer in any way. So here's our roadmap for today. We're going to be dividing what vibe coding is. Then we're going to dive into the potential pitfalls, the dangers, and after that we're going to explore a practical set of practical security playbook, and then finally we're going to cover some actionable items that you can take back with you. So first I want to set the stage with the current landscape. AI's role in software development is just growing, it's exploded. In a GitHub survey from late last year, they showed a staggering 97% of enterprise developers are using generative AI tooling. And something's really important to note is that this is not to say that every single one of these companies has sanctioned the use of these tools. But better than half have. We've got 59 to 88% have allowed or encouraged the use of AI tooling so far. Now this massive and rapid adoption isn't just changing how fast the code is written, and it's not speeding up any old processes, but it's fundamentally shifting how we are interacting with the machine to create the software. It's paving the way for a new paradigm, and it's an approach that we can call coding by feel. So what do I mean by coding by feel? It's this idea that developers are increasingly using natural language. They're expressing their intent, their vibe, rather than meticulously crafting each and every single line of explicit code. They're describing the what and the why, and they're letting AI handle more of the how. There's a shift that's been noted by one of the founding members of OpenAI, Andre, and he captured it when he said that English is becoming the new hot programming language. The term vibe coding was really popularized by his tweet from earlier this year. He talked about a style of coding where you could fully give into the vibes, you can embrace the potential progress of AI, you could forget that the code even exists. It's about focusing purely on the outcome and letting AI handle mechanics. So see stuff, say stuff, run stuff, copy-paste stuff, and it mostly works. The idea of detaching from this underlying code is central to understanding both the appeal and its potential risks. So this isn't just an exercise in defining a buzzword. It's understanding this clearly is really critical, because as we're standing here today, we're at a genuine crossroads on how AI is reshaping development. On one hand, you've got this incredible promise. You've got a true revolution. If you're thinking about this unprecedented speed, the ability to innovate faster and faster than ever before, this radicalization of development where you can bring people's ideas to life, it's exciting and its potential is immense. However, there's the other side of the coin. There is this rapid AI-driven development a potential minefield. Are we, in our rush to embrace the vibe, inadvertently stepping into a landscape that's littered with new, subtle, and complex security threats that we haven't fully grappled with yet? This talk is about honestly looking at both sides of that equation. We're going to explore some of these AI-specific risks, particularly with how they affect the inputs that we're feeding into these AI systems and the output with the code that it's generating. And most importantly, we're not just here to point out the problems, we're going to talk some solutions as well. This is a talk where we can take our existing security knowledge and adapt it to navigate this transformative AI-driven era securely and responsibly. So let's actually make that a more formal definition on our discussion today. So vibe coding is a style of AI-driven development, and a key characteristic that I've seen is that it involves minimal to no code review. Its focus is on rapid output, it's generated primarily from natural language or high-level descriptions, and it doesn't always have the full context of the project. It's intent-driven. You're conveying the vibe, the feeling, the goal, rather than any sort of precise implementation details. It's essentially practical application of that coding by feel that we just talked about, but it's taken to an extreme where scrutiny of the output might be lacking. People are definitely using this approach, and they're leveraging this speed. We're seeing it heavily with rapid prototyping and building out those MVPs. One report mentioned about a quarter of the recent Y Combinator startups are relying on AI for the vast majority of their initial code base. It's really fantastic for generating the boilerplate, accelerating learning in new languages or frameworks, and automating those tedious tasks. And most significantly, it's empowering non-developers, and it's lowering that barrier for people to actually make software. The primary driver is undeniably speed. So let's start to uncover some of those hidden dangers that are lurking beneath all of the speed and convenience. I believe that the risks that are associated with vibe coding fall into roughly 3 categories that we'll go over. So first, we've got dangers that are related to the inputs, and there's some potential for poisoning the well. And second, there's risks talking about the outputs that the AI is creating, that imperfect code. And third and finally, there's significant human and process issues that are arising from how we're interacting with these powerful new tools. So let's start with the input risks. The first thing that I want to point out is config abuse. AI assistants are using config files for guidance, and attackers can embed these malicious instructions into these files. They can use hidden Unicode characters, they can use tricky phrasing, and if these poison files are shared, like in an open source documentation, and it gets used, then the AI is compromised. It's then going to follow these bad instructions, generate vulnerable code, potential backdoors, and there's not going to be any obvious sign of trouble. A more straightforward but equally dangerous input risk is sending sensitive data in prompts. And if you think about it, developers, 97%, are using these, and there's the potential for pasting proprietary algorithms, internal API keys, customer PII, and they're putting this into these prompts that they're sending to third-party cloud-based AI models. And this is going to raise some major data privacy and confidentiality flags. Where's the data go? Who has access to it? How is it stored? And if we don't have any clear policies and awareness, this sensitive information leakage via prompts is a very, very real threat. So let's shift over to the output risks. A fundamental issue is that these AI models are trained on enormous data sets of public code, primarily from sources like GitHub. And it should be no surprise that any public code is going to contain a lot of vulnerabilities in one way, shape, or form. AI is going to be learning these patterns, both good and bad. A well-known study from NYU that was concerning GitHub Copilot, it has shown that AI coding tools can and do generate code with significant security vulnerabilities. Beyond outright vulnerabilities, we all know that AI can hallucinate. That output code looks perfectly reasonable. It might even compile, it may even run without any immediate errors, but it could contain subtle logical flaws or any security flags that are hidden. This is dangerous because it's not immediately obvious, and the code might pass some basic checks, but it's going to fail under specific edge cases or reveal vulnerability later. This can happen because AI doesn't truly understand the security context or anything with the specific nuances of your project. It's just pattern matching, and sometimes those patterns that it is matching, it's subtly wrong or incomplete. Another significant output risk is in dependencies. AI tools might suggest using third-party packages or libraries, and it might sometimes hallucinate those package names that don't exist. This is now called slop squatting. And attackers are monitoring this, or they could be actively poisoning the well themselves, and to create or spine these different fake AI packages that the AI tools are suggesting. They're going to quickly register those names in public repositories like NPM or PyPy, and then they're going to upload that malicious code. And the unsuspecting developer is going to trust the AI's suggestion, install the fake package, and compromise their system. So we also see one other big issue is that AI is suggesting some genuinely real and existing packages, but they're probably outdated because it's trained on all numbers of data, and the outdated versions have known or actively exploited vulnerabilities. Another output risk that impacts maintainability and potential security is code bloat. AI models are lacking that deep project context, and it's sometimes defaulting to the verbose patterns that are learned during training, and they can over-engineer solutions. They might just generate some code that is far more complex, and it's potentially unnecessary for the task at hand. This isn't just an aesthetic issue that I personally deal with all the time. It's unnecessarily complex code. It's harder to understand. It's harder to debug, harder to secure, harder to maintain in the long term. Beyond the direct risks of inputs and outputs, I think that there's also some significant human and process risks as well. There's the danger of over-reliance, potentially leading to skill atrophy, and these developers are stop deeply understanding the code that they're shipping. We also see a last 20% problem. AI is going to get you 80% of the way there, but fixing the remaining subtle issues can be disproportionately difficult. This is going to tie into blind trust, complacency, and developers might assume that AI code is just correct just because it runs. The sheer speed that's enabled by AI, it can encourage rushed and untested deployments, and it's going to bypass critical quality and security gates. So briefly, we're going to touch on ethics. It's a way bigger conversation that above my pay grade. But AI models can inherit and they perpetuate biases from their vast training data. And this can have real-world consequences in the software that it generates. Critically, from a risk perspective, the accountability for flaws or harm that's caused by AI-generated code, it's resting firmly with the developers and the organizations that are deploying it. AI vendors, in their terms of service and in their public statements, have made it very clear that the user is the one that's responsible for validating and securing the output. The OWASP Top 10 for LLMs, as well as their newer agentic AI lists, are excellent resources for thinking through these broader risks. So let's move forward on the playbook for this vibe coding landscape. I've got good news, and I believe that it is the most important message of this whole talk, that we are not starting from scratch when it comes to securing this code. The robust solutions that we've developed over years in DevOps, personally speaking, they're incredibly relevant here. We're not throwing out the rule book. We're adapting these for proven security practices for the unique challenges that AI is presenting. We need to empower ourselves and our teams and remember that security is everyone's job. So the absolute cornerstone of this playbook is human oversight. It's critical and it's non-negotiable. A great mental model that I like to tell everyone is to treat the AI like a very fast, very knowledgeable, but sometimes very naive junior developer or intern. It can produce a lot of work really quickly, but it needs guidance and it needs scrutiny. A good rule of thumb for developers is don't commit any code that you can't fully explain to someone else. It's going to force that understanding. And if you don't understand it, you can always ask AI to clarify it for you or even comment the code. Your existing SDLC and your CI/CD pipelines are your most powerful tools for managing these AI-generated code risks. Why? Because the pipeline doesn't care. It doesn't care whether if a human wrote it, if AI wrote it, if my cat wrote it. It does not care because it's going to apply those same rigorous checks. Automation is always going to be your best friend. We need to trust but verify our code output by ensuring that our pipelines are using SAST, DAST, SCA, dependency verification, secret scanning, all of that, and comprehensive testing. So having your developers requiring unit tests, int tests, end-to-end tests, and more, it's going to be more and more critical to catch these subtle logical flaws that AI has been known to introduce. So what's all this look like in practice? That's a long list. But at this point, I'm hoping that we have some of these tools in our ecosystems in place, and if you don't, now is the time to get it in play. You should be using SaaS tools to find some common vulnerabilities in your code, SCA tools to check those dependency names, and all the sources against the potential AI suggestions. Implementing secret scanning so that we don't have security secrets in code. Pearson got popped this week because someone put their personal API token in their repository. Yeah. And we have to reinforce all of these automated checks with process, requiring peer code reviews, human peer code reviews, for any and all code commits, including those that are significantly filled with AI-generated portions of text. And enforcing just plain old coding standards like linting. Requiring a certain percentage of code coverage with unit tests is also going to help. Other tests like integration and end-to-end are going to maintain that code sanity. So I'm going to encourage all of you to have your teams investigate both open source as well as enterprise solutions for all of these, because together these tools and methods are going to help get us closer to securing those outputs. We also need to be smarter about how we talk to the AI, practicing secure prompt engineering. Be explicit about your requirements and your prompts. So don't just ask for a login function, instead ask for a login function with password hashing and protection against timing attacks. I'm going to regularly advise my own favorite technique, which is to ask AI the security considerations of the code that it just output, because sometimes it can catch things and then you can reverse engineer from there. Critically avoid putting any sensitive data like API keys or proprietary logic into these because it's third-party cloud models, and unless you understand the data and the risk of what you're putting in there, you're accountable. And finally, use sandboxed environments for that initial experimentation, and that's going to limit the blast radius. So for larger projects, especially those that are involving significant AI generation, structured workflows can make such a big difference. And this is going to involve defining clear PRDs, planning your implementation in manageable vertical slices, like building features end-to-end incrementally, and even using AI to help develop your documentation to maintain that context. So underlying all of this is the need for clear team communication and established guidelines. What tools are approved, what data can be shared, and what are the review standards of this AI-generated code. There is essential conversations that, as a security folks, we can build policies around. And finally, the most crucial part of this playbook is acknowledging that this field is evolving incredibly fast. So every day there's new AI capabilities, which also brings new attack vectors, which leads to new defense techniques. And this is going to be emerging constantly. So we need to commit ourselves to that continuous learning. Staying informed by following different security researchers, reading publications, attending conferences like this one. It's a place where you can share with your teams, participate in the broader security community, because that adaptation is going to be key to staying ahead. And all that being said, what steps can you take away from this talk? Go back and implement. Let's recap some of the things. So quickly, we've got that vibe coding is a trade-off between speed and risk. And we've got risk with the input side as well as the output side. But the crucial takeaway is that accountability for managing these risks lies with us. Everybody in this room, this lies with us. The developers, the security teams, and the organizations that are deploying and recommending this technology. So first, I would tell you to go ahead and conduct a vibe check on your organization's AI usage. Understanding how these tools are being used. So sometimes this has to go above just emails and messages. I would advise you guys to make connections, right along with the developer teams, and getting involved in the planning stages of projects. It's hard, I know, trust me, you can do it, I believe in you. Secondly, I would tell you go ahead and educate your teams on secure prompting practices and the need for going through rigorous code reviews. And third, I'm going to say scrutinizing that, integrating the security into the workflow, automating your checks wherever you're possible within your pipeline, and scrutinizing. Apply that critical thinking, rigorous verifications to both the inputs and outputs of AI systems. So the goal here isn't just to discourage the use of powerful tools, because developers are going to use them whether they publicly admit to it or not. Don't forget that 97%. At this point, what we need to do is harness their potential and do that responsibly and securely. Because if we are fully leveraging and adapting our existing toolkit, we're being mindful of our inputs and rigorously scrutinizing those outputs, I think that we can learn to vibe securely. So, thank you.